When I was a young man, long before the world placed upon my shoulders the heavy robe of relativity, there was a quiet assumption that rested unquestioned in the foundations of physics. It was not written in any equation, nor carved into stone tablets of doctrine. It was simply believed. Time, we thought, was absolute. Imagine this old vision of the universe, a vast cosmic stage upon which events unfold. The stage itself, space, is rigid, unmoving, a silent scaffold. Above it ticks an invisible master clock, its rhythm uniform and sovereign. Whether on Earth, on Mars, or drifting between the stars, this clock governs all. 1 second here is 1 second everywhere. The present moment is shared by all beings, from the humblest insect to the most distant galaxy. The universe breathes in synchrony. This idea was given its most elegant mathematical form by Sir Isaac Newton. In his framework, time was independent of space, independent of motion, independent even of the events it measured. In modern notation, one might express this old assumption symbolically as T equals T. This simple expression captures the ancient faith. The time coordinate measured by one observer, T prime, is identical to the time measured by another, T. No matter how they move relative to one another, time flows the same. Such a statement seems innocent. It feels natural. After all, when you and I stand together and watch two bells ring, do we not agree whether they ring at the same moment? Surely simultaneity is a universal fact, not a matter of opinion, but physics is not built upon what feels natural, it is built upon what nature permits. The discomfort, the itch in the mind began when I considered the nature of light. James Clerk Maxwell had already given us the profound equations of electromagnetism. From these equations emerged a remarkable result. Electromagnetic waves propagate through empty space with a speed c. This speed was not relative. It was fixed, woven into the structure of the equations themselves. Yet if time were truly absolute, as Newton imagined, then the speed of light should obey the simple rule of addition of velocities. In that old world, if a beam of light travels at speed c, and you move toward it at speed v, you should measure its speed as c plus v. Conversely, if you move away, you should measure it as c minus v. Symbolically, the Newtonian expectation would be c equals cv, but experiments, most notably those of Michelson and Morley, stubbornly refused to comply. The measured speed of light remained c, independent of the motion of the observer. Nature was whispering something radical. If the speed of light is invariant, if every inertial observer measures it as c, then the equation c equals c must hold, regardless of motion. This single insistence fractures the idea of absolute time. Let us imagine two observers, one standing on a platform, another riding a train gliding past at constant velocity v. According to Newton, they may disagree about positions, but they must agree about time. Their clocks, if properly synchronized, should tick in harmony. Again, the Newtonian statement is simple, T equals T, but if both observers measure the same speed of light, then something else must give way. We cannot preserve both the invariance of C and the absoluteness of time. The mathematics demands a sacrifice. To preserve C equals C, we must allow the transformation between observers to mix space and time. The correct transformation, what later became known as the Lorentz transformation, tells us that time in one frame depends not only on time in another, but also on position and velocity. In simplified form, the relation becomes T equals TVXC. Here, the Lorentz factor is defined as equals 1 VC. Observe the profound shift. Time t prime depends on position x. Time is no longer universal. It is entangled with space. If two events occur at different positions, say, one at x and are simultaneous in one frame such that t equals 0, then in another frame moving at velocity v, the time difference becomes t equals vxc. If x is not 0, if the events are separated in space, then t is not 0. Events simultaneous in one frame are not simultaneous in another. This is the collapse of absolute time. The equation T equals Vxc is not merely algebra, it is a philosophical earthquake. It tells us that simultaneity depends on motion. The universe does not possess a single shared now. Each observer carries their own slicing of spacetime, their own definition of the present. The master clock dissolves time, once imagined as a flowing river identical for all, becomes something more subtle. It bends and stretches. It entwines with space into a single fabric we now call spacetime. The separation between when and where is no longer absolute. It is relational. Thus, the first pillar of relativity stands revealed. The assumption T equals T must be abandoned. In its place rises a deeper truth that time is not an independent stage upon which events play, but a participant in the drama itself. And this realization, though born from equations, is profoundly human, for it asks us to relinquish certainty. It asks us to accept that our intuition, shaped by slow speeds and gentle motions, is not the measure of reality. The universe is under no obligation to conform to our habits of thought. To question time itself, this was the beginning. Permit me now to invite you into a small theater of the mind, a Gedanken experiment. A thought experiment, for it is often in imagination that nature reveals her most guarded secrets. Picture a long train gliding smoothly along a straight track with constant velocity v. The motion is uniform. There is no jolt, no vibration. Inside one carriage sits an observer exactly at its midpoint. Outside, standing upon the platform, another observer also positions herself precisely at the midpoint of the train's path as it passes. Now imagine that at the precise instant the middle of the train aligns with the observer on the platform. Two bolts of lightning strike the front and the rear of the train. Before we proceed, let us recall the old intuition, the Newtonian comfort. If two events occur at the same time for one observer, they occur at the same time for all. In symbolic language, that belief was expressed as T equals T. This was not merely mathematics. It was a metaphysical conviction, but let us now test it. The platform observer sees the lightning strike both ends of the train, because she stands exactly midway between the two strike points. And because light travels at speed c in all directions, she receives the light signals from both flashes simultaneously. Since the distance to each strike is equal and the speed of light is c, the arrival times are identical. In simple reasoning, if distance equals d and speed equals c, then time equals d divided by c, the time for each flash to reach her is d over c, equal distances, equal speeds, equal times. Therefore, the two lightning strikes occurred simultaneously in her frame. Mathematically, she concludes, delta t equals 0. For her, the time difference between the two events vanishes. Now let us enter the train. The observer seated at the midpoint of the carriage is not stationary relative to the platform. He moves forward with velocity v. When the lightning strikes occur, he is not fixed between the two flashes in the same way as the platform observer. Consider carefully what happens. The flash from the front of the train must travel backward toward him. The flash from the rear must travel forward toward him. But he himself is moving forward toward the light coming from the front strike and away from the light coming from the rear strike. Now remember the sacred principle. Every inertial observer measures the speed of light as c naught c plus v naught c minus v, simply c. In the old Newtonian expectation, one might have reasoned that the light approaching from the front would meet him at speed c plus v, and the light from the rear would approach at c minus v. That would preserve simultaneity. But nature refuses this arithmetic. The speed of light remains c for him as well. So what changes? The distances do, because he moves toward the front flash. The distance that flash must traverse to reach him is shortened. Because he moves away from the rear flash, that flash must cover a greater distance. If the speed is the same c but the distances differ, then the arrival times must differ. Time equals distance divided by c. A shorter distance means a shorter time. A longer distance means a longer time. Thus the observer on the train receives the flash from the front first and the flash from the rear later. He concludes, delta t prime does not equal 0. The events are not simultaneous in his frame, and here lies the paradox. Both observers are correct. The platform observer insists the strikes were simultaneous. Because the light reached her simultaneously and she was equidistant from the strike points at the moment of emission. The train observer insists they were not simultaneous because the light reached him at different times and the speed of light for him is also c. No illusion, no error, no faulty clocks are involved. The disagreement arises solely from their relative motion. The mathematical structure supporting this is embedded in what we later called the Lorentz transformation. The relation between time measurements into frames moving at velocity v is t prime equals gamma multiplied by the quantity t minus vx divided by c squared. Here gamma equals 1 divided by the square root of 1 minus v squared over c squared. Notice the subtlety. Time in one frame depends on both time and position in another. The term Vx divided by c squared is the silent architect of the paradox. If two lightning strikes occur at different positions, meaning delta x is not zero, and if they are simultaneous in the platform frame so that delta t equals zero, then the time difference in the train frame becomes delta t prime equals negative gamma multiplied by v delta x divided by c squared. Unless delta x equals zero, this expression cannot vanish. Motion transforms simultaneity into sequence. What once appeared to be a universal now fractures into many nows, each belonging to its own frame of reference. This is not a trick of perception. It is not a matter of signal delay. Even if the observers correct for the travel time of light, the conclusion remains. The relativity of simultaneity is built into the geometry of spacetime itself. The train and lightning scenario is simple, almost childlike in its imagery, yet within it lies the dethronement of absolute time. It reveals that simultaneity is not a property of events alone, but a relationship between events and observers. And so, through this modest moving train and two flashes of lightning, the universe confesses something astonishing. There is no single cosmic clock declaring what is happening right now everywhere. Each observer carries their own slice of spacetime, their own definition of the present. The train moves on, the lightning fades, but the old certainty of universal time does not survive the journey. There are moments in science when one does not discover a truth, one submits to it. The third pillar of our discussion is not born from speculation, nor from philosophical rebellion against Newton, but from obedience to experiment. It is the principle that reshaped space and time not by choice, but by necessity, the speed of light in vacuum is the same for all inertial observers in its simplest symbolic form. This principle says c equals constant. More precisely, if one observer measures the speed of a beam of light as c, and another observer moves past at velocity v, the second observer also measures the speed as c naught c plus v naught c minus v simply c. This assertion is deceptively small. It appears almost harmless. Yet it is the quiet dictator of relativity, the uncompromising law from which all else follows. In classical physics, velocities add in the most intuitive way. If a carriage moves forward at speed v, and a ball is thrown inside it at speed u relative to the carriage, then the speed of the ball relative to the ground is u plus v. Symbolically, one would write u prime equals u plus v. This is the arithmetic of daily life. It is how we have learned to think about motion. But Maxwell's equations of electromagnetism, those magnificent creations of James Clerk Maxwell, revealed something extraordinary. From them emerges a wave equation whose solutions propagate with speed. C equals 1 divided by the square root of mu naught times epsilon naught, here. Mu naught represents the permeability of free space, and epsilon naught its permittivity. These are not properties of motion, they are properties of the vacuum itself. Thus light does not borrow its speed from its source, it carries its speed as part of its nature. Experiments, particularly those of Michelson and Morley, attempted to measure variations in the speed of light due to Earth's motion through a supposed ether. They expected to find differences something like c plus v in one direction and c minus v in another. But the result was stubbornly clear. No such variation appeared. Thus nature insisted, c prime equals c, and here the crisis began. For if we cling to Newton as absolute time, if we maintain that t prime equals t and we preserve the classical addition of velocities, then we cannot keep c invariant. Something must break. The salvation lies in surrendering the absoluteness of space and time to preserve c prime equals c for all inertial observers. The transformations between frames must change. Instead of the simple Galilean relations, x prime equals x minus vtt prime equals t, we require new relations, the Lorentz transformations. X prime equals gamma multiplied by the quantity x minus vtt prime equals gamma multiplied by the quantity t minus vx divided by c squared, where gamma equals 1 divided by the square root of 1 minus v squared over c squared. Observe carefully what has happened. Time now depends on position. Space now depends on time. They are intertwined. This interweaving ensures that when one calculates the speed of light in the moving frame by dividing distance by time, one again obtains c. The invariance of light demands the relativity of simultaneity. Let us examine this more deeply. Suppose a pulse of light is emitted at the origin at time t equals 0. In the stationary frame, its motion satisfies x squared plus y squared plus z squared equals c squared t squared. This is the equation of a sphere expanding outward at speed. See, now consider a moving observer. If the speed of light is truly invariant, then in that observer's coordinates the pulse must satisfy x prime squared plus y prime squared plus z prime squared equals c squared t prime squared. The form of the equation must remain unchanged. This requirement that the structure of the light cone equation remain intact constrains the transformation between frames. It demands the Lorentz transformation. In effect, the universe protects the equation x squared plus y squared plus z squared equals c squared t squared the way a composer protects a melody. No matter the key, no matter the tempo, the theme must survive. From this preservation emerges the invariant spacetime interval. S squared equals c squared t squared minus x squared minus y squared minus z squared. This quantity remains the same for all inertial observers. Notice what this tells us: the combination of space and time. Into this single expression S squared is invariant, not space alone and not time alone. Light's invariance forces us to redefine reality. The constancy of C is not merely about electromagnetism, it is about causality. If signals could exceed C, cause and effect would fracture, the ordering of events could reverse, the structure of spacetime would unravel. Thus C is not simply a speed, it is a boundary, a horizon in the geometry of existence. And because this boundary must appear identical to all observers, the geometry itself adjusts, clocks slow, lengths contract, simultaneity shifts. It is as though spacetime bends itself to preserve this single sacred principle. The relativity of simultaneity is not an arbitrary feature of mathematics. It is the direct offspring of light's invariance. If the speed of light were not constant, time could remain absolute, but because c equals constant for all inertial observers, time must become relative. Thus, the speed of light is the silent sculptor of spacetime. It dictates how measurements relate. It enforces humility upon our intuitions, and so we arrive at a profound realization. The universe is not built around our sense of motion. It is built around the constancy of light. From this single principle C equals constant flows the transformation of our understanding of time itself. Light does not merely illuminate objects. It illuminates the structure of reality. If you ask an ordinary person what time it is, they will look at their watch and answer with confidence. If you ask what is happening right now in a distant city, they will imagine that somewhere beneath a different sky, perhaps events are unfolding in the same present moment they inhabit. This instinct runs deep, it is not taught. It is assumed the universe, we believe, shares a common now. There exists a cosmic present slicing across space like a vast invisible sheet, dividing the past from the future. But relativity, with quiet ruthlessness, dissolves this comfort. From the previous reasoning, we have seen that if two events are simultaneous in one frame, meaning that delta t equals 0, then in another frame moving at velocity v, the time difference becomes delta t prime equals negative gamma multiplied by v delta x divided by c squared. Here gamma equals 1 divided by the square root of 1 minus v squared over c squared. Let us contemplate this expression not as algebra, but as philosophy written in symbols. If delta x is not 0, that is, if the events are separated in space, then delta t prime cannot be 0 unless v itself is 0. In other words, simultaneity depends on motion. There is no universal now. Consider two distant stars that explode at what one observer judges to be the same instant. For that observer, delta t equals 0, yet for another observer, moving relative to the first, the explosions are separated in time by an amount given precisely by negative gamma multiplied by v delta x divided by c squared. Which observer is correct? Both. This is the great revolution. Simultaneity is not an absolute property of events. It is a relationship between events and observers. To understand this more deeply, let us step into geometry. In Newton's world, time was like a universal axis running perpendicular to three-dimensional space. One could imagine slicing the universe at constant t, a clean horizontal cut. That slice represented now everywhere, mathematically. This was the assumption that time was independent and identical across frames. T prime equals t, but under the Lorentz transformation, time mixes with space. T prime equals gamma multiplied by the quantity T minus Vx divided by c squared. Notice that surfaces of constant T prime are not horizontal in a spacetime diagram. They are tilted. If you draw spacetime with time on the vertical axis and space on the horizontal axis, then the line representing now for one observer is not the same line representing now for another observer in motion. Each observer carves the universe differently. This tilting is not a metaphor, it is encoded in the invariant interval s squared equals c squared t squared minus x squared minus y squared minus z squared. This quantity remains unchanged under Lorentz transformations, but notice what is preserved, not time alone, not space alone, but their combination. Time and space are not separate kingdoms, they are provinces of a single structure spacetime. Now let us examine the deeper consequence. If there is no universal simultaneity, then the distinction between past, present, and future becomes observer dependent for events that are separated in space but not causally connected, events that lie outside each other's light cones, meaning that the separation satisfies the condition that x squared plus y squared plus z squared is greater than c squared t squared cannot influence one another. Their temporal order can differ depending on the observer. One observer may judge event A to occur before event B, another may judge B before A, yet causality remains. Safe for events that can influence each other, those inside the light cone, where c squared t squared exceeds x squared plus y squared plus z squared, the order remains invariant. Thus, relativity does not create chaos, it creates structure. The absence of a universal now means that the universe is not evolving in a single synchronized heartbeat. Instead, each observer carries their own temporal slicing of reality. Imagine two astronauts drifting past one another in deep space. Each defines their own plane of simultaneity, their own present moment, the now of. One intersects the world line of the other at a different point than vice versa. It is as though the universe is a vast four-dimensional block, and each observer draws their own three-dimensional cross-section through it. This view has sometimes been called the block universe interpretation. In it, past, present, and future coexist within the geometry of spacetime. What changes is not the existence of events, but the observer's perspective. And here lies the final philosophical tremor. The present is not a universal feature of the cosmos, it is local. Your now does not extend across the galaxy as an absolute decree. It is defined by your motion, by your state of reference, by your world line through spacetime. This realization can feel unsettling. It seems to strip the universe of a shared immediacy, but in truth it reveals something more subtle and more beautiful. Reality is not built around a cosmic clock, it is built around relationships. The equation delta t prime equals negative gamma multiplied by v delta x divided by c squared is not merely a correction term, it is the mathematical signature of a deeper unity, that time and space are woven together, and that what we call the present depends upon how we move through that fabric. Thus the final pillar stands, there is no single universal now, there are many as there are states of motion, the universe does not tick, it unfolds. And we, as observers, participate in the way it is divided.